to the channel. So in this video we are going to do an interesting assignment of finding the location of a star from my home in respect to my home. So particularly we are going to focus on Polaris, which is Dhruv Tara. Okay, so it is a part of Ursa Minor constellation and is very important for detection of the north direction because its location remains constant in the sky. Okay, we are going to find it out. Here you can see a beautiful image of this north star. So we are going to start by importing the AstroPy.units as you, and then coordinate modules like sky chord, earth location for specifying the location of the observer, then alt z for the horizontal coordinates, and the get sun for the coordinates of sun and all. Okay, it is going to contain the information of sun and sky chord, yeah, for constellation and stars. Okay, so first we are going to define the location of observer. So we are going to use earth location. So here we have given latitude and longitude for the observer. So for your location you can define it by simply googling it. So I have googled it, location of Jagadari, longitude and latitude. So in two formats you can get the following information, which is in north and east as well as in minutes second. So according to the data you are getting, so you can define the this units say. Okay, like I have taken it in the arc minutes format. So I have defined it 30 degree and 10 arc minutes and 21 arc seconds. Okay, so in the same way you can define it in degrees as well. Okay, yeah. So next we have defined a simple function phi, which is the latitude, observed latitude. Okay, so after that we are going to specify the time. So we have to adjust the time according to India. So India is 5.5 hours ahead from the UTC time which is given. Okay, so we are going to give the UTC shift as 11 by 2 hours. Okay, which is IST time, which is going to convert it to IST time. So as we are ahead we are going to subtract it so that we'll get in the same reference frame. After that we are going to import numpy, and we are going to define the interval for which the following measurement will be calculated. So we have taken it for a day. This is the date we are giving. Okay, on this date we are observing this, and we are given the interval of 5 minutes, that every 5 minutes our data point will be collected. So yeah, this is the time for which we are going to evaluate it. After that we have defined the frame location according to 24 hours. Okay, 24 hour we are taking. So now this is the important part. If you want to calculate it for Polaris, you are going to specify the name of Polaris here, and for any other star you just have to change the code here, and in this section and this section, in both of the section you have to change the plot if you want to get some data for other star. Okay, we are going to discuss it in a while. Okay, so yeah, so we have given the sky coordinate. After that we have transformed it to frame 24 hours format, and then we have defined the sun coordinates, and we have also defined it to frame local 24 hours format. Okay, so the time dependent coordinate of sun in equatorial system. Okay, now after we have gathered all the data for the star and the sun, and also our location, we are going to plot it as this. So first we are going to import matplotlib and the other modules related to it. After that yeah, so what you can see here, that when the sun is up here, so the star line we have given it dotted here, and when it is in the night time, so the star line is solidified. Here we have solid line for the star in night time. So it specifies that when in the presence of sun the star is not visible to us, whereas at night it is visible. Okay, so we are given this here in this code. We have defined it here, that sun location dot old, if less than 0 then yeah. So here we have defined it condition according to above. We have specified that it is going to be red, solid red for night time, and all of this we have defined it, and we have saved this plot in the save PDF by giving the save PDF argument in a form of PDF. Okay, Polaris observation window, and we have in the y-axis defines the altitude of the sun and the star, and the x-axis gives the time. Okay, so here in this way you can do it very easily. So we are going to calculate it for the Rigel star. It is a part of Orion constellation, which is at the bottom right. So let's see how we are going to do this. So we are just going to take this the star by name code block and paste it here, and we are going to use Rigel in the place of Polaris. Okay, RIGL Rigel, and we are going to define it here as well. So what I am going to do, I am going to RIGL Rigel. I am going to copy it, the Rigel name, and then replace it by Polaris. Okay, I think there is a special function which can do this, but we are going to do this in this way only. Okay, so here we have defined the first block, then we are going to give the second block of code which is going to plot the graph for us. So yeah, it is executed successfully. Now I am going to change it the Polaris to Rigel in this piece of code. Yeah, so oh shit, I have to do it again. It multiplies 2 times, so I am going to remove this first, then going to give it again. So I have to again copy Rigel from here, or you can just type it on, does not matter much. Yeah, so here we can find, yeah, here Polaris is written over here. So I'm going to delete it and place it with Rigel. So I have deleted it. Now Rigel, now here also it is Rigel. Now yeah, here also it is Rigel. So you can see that we have to just give minute changes to our code to get our location for the new star. Okay, Rigel, and if you could see, yeah, we are just going to initialize it, and if there is any problem we can just sort it there only. Okay, so let's see. I think yeah, we have to change it also so that it will not store in the same file corrupted. So we are making a new file in which the following Rigel will be stored. Rigel file will be stored. Okay, let's initialize this. Yeah, so here we are getting this data. I think I have to increase the y limit in order to see it very clearly. So yeah, after adjusting the y limit, so we can see that the Rigel coordinate as well as the sun coordinate is visible in the light time, and makes an altitude, it has a decreasing altitude, that it is going to disappear at some point of time. Okay, so here in this way you can calculate it for other star as well by just simply searching on Google list of stars, and you can perform this same code out different stars. And if you want to get any information about any working module, you can just type it on Google. Hope you find this video informative and fun. So keep trying, keep using this code, and you can find this code on my GitHub. The link for the GitHub is given in the description. And yeah, so see you in the next one. Okay, bye.
Get on my head. 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 Get on my head.